All right, so I'm going to record the screencast for 8.2 in this class. So this will help us with understanding section 8.6. So as I've already stated, for people who aren't here watching the screencast, we're going to be working on 8.2. And then we're going to have a little quiz before spring break, and then we will resume with 8.4 and 8.6 after spring break. Cool. All right, so adding and subtracting rational expressions. So first, let's talk about rational. What's a rational expression? Do we know? Close. Let's see. A rational expression is rational has the word in it. Ratio. So literally dealing with fractions. So I know that's your absolute favorite thing in the world is fractions. So we're going to break it down. Okay. So the first step, right, whenever you found the least common denominator, you had to look for any factors that they had in common or the least common multiple. So normally the least common denominator is the least common multiple. So that's what the LCM is standing for, is least common multiple. LCD is least common denominator. So we're looking for the number that both of denominators can go into evenly, but we want the lowest number, not just any. For instance, if I have the least common multiple of 2 and 4, I mean, I could say, oh, you know what, 40. 40 is a multiple, right? 40 is a common multiple of 2 and 4. I can multiply 2 by some number, get to 40. I can multiply 4 by some number, get to 40, but this isn't the least common. What would be the least common? 20, 8, 4. So I want the biggest number that both of these can go into. I don't want the least common factor, I want the least common multiple. So factors are like product. Multiples are like you're multiplying the number. Factoring, you're finding things that multiply to that one number. So least common factor of 2 and 4 would be 4. Okay, so let's find the least common denominator of example 1. So I have 4, 6, and 2 ninths. What would be the least common denominator?
18.
We say 18? Say 18? How is it 18? How do you know?
Because 9 times 2 is 18, and 6 times 3 is 18.
Yeah.
Did you already hand out the paper?
I did hand them out. All right.
Oh, I get it.
No, so like previous class, or this is.
Right now.
Oh, okay, yeah.
Yep. All right, so we said 18. So I list out the multiples of 6, 12, 18, 24, 30. List out the multiples of 9, 18, 27, 36. I see that this 18 is the least common multiple. So that's going to be my smallest common denominator. So in order to rewrite this, Jack, how would I rewrite these two fractions?
12 over 18 and 4 over 18.
12 over 18 and 4 over 18. Okay, so how'd you find those? Can you describe that?
Because in order to get 6 to 18, you multiply by 3.
Maybe I'm on the wrong password.
Sorry.
That means you also have to multiply 4 by 3.
So if I'm multiplying 6 by 3 to get a common denominator of 18, I have to multiply the top by that. What's 3 over 3 equal to? 1. And any time you multiply a number by 1, you'll get back itself. You're not changing the problem. So multiplying by 3 over 3, that's basically multiplying by 1. Then over here, he said we're going to multiply by 2 over 2 because to get to 18, you have to multiply 9 by 2. Okay. How do we feel about this? Good review? We understand it? Because if you don't understand this, well, that's it for today then. Well, it would be rough. It's going to be rough. Okay. As long as we're good. Let's try this one. What would be the least common denominator? Let's see. So I have 4 over 1, 2 over x plus 1 and times x minus 2, 1 over x times x plus 1. So I need something that all of these can go into. So I see that there's an x plus 1 right here and an x plus 1 right here. So I think my least common denominator needs to have an x plus 1 in it. Oh dear, you know what that means? I'm going to have to multiply 4 by an x plus 1 over x plus 1.
What about x plus 2 then?
Okay, so hold on. So, okay, I got that factor. Figured out. I have an x minus 2. So I'm going to have to, that's going to have to be part of my common denominator. So I'm going to have to multiply each one that doesn't have an x minus 2. I'm going to have to multiply by it.
That's like literally so unnecessary.
That's how it seems.
It's okay.
Oh my god.
Please don't comment on other people's sneezes.
I'm sorry, I really do.
Please, like, do you see this little distraction that just took up time? Let's not have those anymore. We're not going to beef anymore. We're going to be kind to each other, and we're going to get through this stuff.
We won't be.
So you need to turn your phone, like, silent.
Yeah.
Like, right now, I'm going to tell you, get it out, put on silent, then you're going to put it in your backpack, not your pocket. Thanks. Okay. Okay, so I have an x minus 2. Maybe I should just be talking about the denominators before I make them all be the same. So I have to multiply this by x minus 2. Okay, so now they all have a denominator. Can you guys see that? They all have factors of x minus 2 and x plus 1 in the bottom. What else do I need to do? Yeah, because I have this stinking x right here, so I need to multiply it all by x.
Wait, do you also have to write x minus 2 on the left side, or you just wrote that there? Oh.
So I want them all to have the same common denominator. Oops, I didn't need to write that right there. I just need to write it right here. Cool. So now I see all three of them have the same common denominator. X minus 2 times x plus 1. X minus 2 times x plus 1. X minus 2 times x minus 1, x plus 1. Like, they all have this common denominator.
Yeah.
So if there's like, if they all have the same factors on the bottom, cool, we're good. But if there's some different factors, you might end up having to like multiply them. So just like when we were working on 8.1, you need to fully factor your problems out to see if anything crosses out. Here, you need to fully factor the bottom out to see if there's any factors that are not common between them. Okay, it's a little confusing, but let's find the least common multiple of each set of polynomials. So the least common multiple. So what is least common multiple? Yeah, so what?
Wait, that's it? We don't even have to...
Wait, can you go back up to that?
Sorry.
Don't you have to multiply anything?
No, this is, I'm trying to like walk you guys through, like give you this skill. So I'm trying to like baby step you guys through this, give you like one part of everything, and then we'll put it all together instead of being like, here, tons of methods and crazy. So, understanding how to find the least common denominator, step 1. Yes.
Wait, are you doing in that?
Yeah, I'm gonna go down to.
You
Okay.
just have to like take out all the most. Is it least common multiple or greatest common multiple?
So I want the least common multiple. So I see I have some stuff in common, right? Like they all have a c, right? So they all have at least c squared, but I need to know what would be the least common multiple of each polynomial.
C would be 2.
So you want to deal with c first?
Isn't it 2?
These two.
Huh.
No, it would be 6.
That's the highest.
Yeah, so
Oh, it's 6.
Basically, What I'm saying is if these were the bottom of a fraction, how can I make them all have the same, like,
You multiply the C2 by 3 and the C3 by 2, and then they'll have C6. Like a G.
so I see that C6, I could multiply each of these by some C, like this I could multiply by C cubed, this I can multiply by C to the fourth, and that would get me up to C to the sixth.
Oh, wait, I?
When you multiply bases, you add the exponents.
Right.
So I'm multiplying C to the third times C to the third. That's the same thing as C to the 3 plus 3.
Right.
Okay. Let me just move that out of the way. Okay, so that I have the C's, I'm good there. What about my B's? What's the least common multiple? Huh? Of B, of the B letters. So I'm going through the letters first. So I see, let's see, here's a B, here's a B. The least common multiple would be B to the fifth. This would be 5. Where's my bullet? This is it. So B to the fifth. Okay, so that means that I don't have to multiply the middle guy because I already have B to the fifth. This very right side doesn't have any B, so I have to multiply by B to the fifth. And on the left side, what do I multiply by? B to the fourth, right? Because if I do B times B to the fourth, that's going to be B to the 1 plus 4, which is B to the fifth. Okay, you know what? Maybe I will show. I'll just write what I did before. That way it's part of the notes. Okay, so I'm trying to distinguish for you guys the difference between common multiple versus what I have to multiply each denominator by in order to have it reach the common multiple. Okay. So I'm trying to distinguish, like, what would be the least common multiple versus what do I have to multiply each term by in order to get to the least common multiple. All right, so if I go through A, what would be the least common multiple? The A? What'd you say? Well, let's see. I have a squared. I have an A cubed. Let's see, I have A squared, A cubed. What's the least common multiple? So I want it to be A cubed.
Yeah, that's what I said. I said that. If I get some more brownie points for it.
So I'd have to multiply this first one by A, because when I have A times A squared, that's going to be A to the first, A to the 1 plus 2, which is A cubed. The middle part doesn't have any A's, so I'm going to have to multiply that by A cubed. And on the right side, guess what? I have A cubed, so I'm good. That's all I have to do. Okay, and now the numbers. So I think the numbers are probably the hardest part, but this is the part you have the most experience in. So I'm going to list out the...
I've been doing that for a while now, so I haven't found the formula.
I'm going to list out the factors. So factors of 15 are 3 and 5. Factors of 16, 4 and 4, which is 2, 2, 2, 2. 20 is 4 and 5. So I did the prime factorization of all of these. Okay, and now I'm going to, I need another highlighter color. Let's see. Okay, cool. So I see a 5 here, I see a 5 here. What do you think I need to do? I see a 5, 5. I'm looking for
I have no idea.
the least common multiple. Okay, so 15 and 20 have a factor of 5, meaning, okay, you know what? Let me pause a second. Okay.
They could both be 60, right?
Well, 15 and 20 can both go into 60, but 16 can't go into 60.
I think I got it. I got it, Chief. I got it, Chief.
No, not quite.
I got it. It's
So
Can you just multiply all them together?
multiply this by 5. I
got
could multiply it all together. And then I see that I have a
It's
common.
9, multiply by 9.
There's 2 here. There's a 2. So I need to multiply.
Oh, that's cool.
There, multiply by
Let me
9.
okay.
You
Let me think about this. How can I
150.
describe what I'm doing? I'm seeing all the prime factorization. So I saw that the outer 2 had a 5 and the middle did not. So I'm trying to find the smallest number that all of these are a factor of. And instead of multiplying them all together or listing them out like 20 different factors, I'm saying, okay, I'm trying to take into account all of their prime factorization. This is a little hard, but you know what? You can do it. So on the very right side, I started with the 5. I saw there was a 5 in the 15 as well. So I'm like one step. I see I have one factor in common. With 20 and 16, they both have a factor of 4. So I have that in common. I also see I have a 3 right here. Well, shoot, none of the others have a 3. So I have to make sure multiply by 3 on all of these. And now I have this other little factor of, I have these last 2 factors right here.
60.
Oops, I didn't want to do it. I wanted to do it to the other one. So not only does this tell me what my lowest common multiple is, it tells me what I have to multiply each term by. So let's see. 5 times 2 is 10, times 2 is 20, times 3 is 60, times 2 is 120, times 2 is 240. My least common multiple is 240.
I was almost there.
Imagine listing this out. If you're going 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240. Okay, so the 12th term, 15. Oh my gosh, that would be the 16th term that you listed out. So while this way is like a little more complex, it tells you what you have to multiply each term by. So I have to multiply the term with the 15 by, what's 2 times 2 times 2 times 2? 16. What is 5 times 3? Multiply by 15. 3 times 2 is 6, times 2 is 12.
Hold on.
So if this was a common, if I was trying to make a common denominator, this would be like hell problem, because this is rough, right? Now you have to like multiply the top by this, blah, blah, blah. But we found the least common multiple, least common denominator is 240 times a cubed, b the 5th, c the 6th.
Wait, I have a question. For the least common multiple, we factor them out. How do we know what numbers to multiply? Because it's like there's 4 2s.
Yep.
But there's like a lot more, and I know you bunched them up together, but then there's like no 3s to match with.
So okay. So first I started with the 5. I said, okay, there's a 5 over here, meaning I have to add it right here in the middle since there wasn't one. I see a 3. There's no other 3s, so I had to add it down here because I'm trying to see what I have to multiply by. A set of 2s, a set of 2s, so I have to multiply by a set of 2s here. And then lastly, I have this lonely set of 2s that I'd multiply the other 2 factors by. So I went through to try to find, like, I have to include all of the factors, but I don't want to just straight up multiply everything together. Maybe the next example will be a little better. This was a little bit crazy. All right, find the least common multiple of each set of polynomials. Okay, so first step, how can I find if they have anything in common? Factor. All right, let's factor. How do I factor? What's the first step? I should factor with this left guy. Exactly. Take x out. Tatiana, what will I have left?
X times x squared minus x times 2.
Good. And can I factor this middle part further?
Minus 2 plus 1.
Awesome. Now let's do this other side. How can I factor this guy out? Let me pause for a second. Do you understand how we got these numbers? Maybe we should go through that. So she pulled out an x because she saw every single term had an x in it. That's how she knew she could pull it out. Is that sun blinding you? Okay.
It was blinding me.
Oh, I'm sorry, I didn't see it. Because we're looking for what adds to -1. Multiplies to -2. So that's your A, which is 1, times your C, which is -2. So we say, okay, -2 and 1, when you add them, you get -1. When you multiply, you get -2. Okay, so let's do the other side. I need something that's going to add to -4, but multiply to a +4. -2, -2. Okay, so I have x minus 2 and x minus 2. Okay, so for my least common denominator, I need to include all of the factors, but I don't want to have to repeat things more than once. So if I multiply these together, I would get x minus 2 times x minus 2 times x minus 2. Versus, if I look at what they have in common, I have one less factor of x minus 2. Because I already took that into account. Was that confusing? I think so. Let me back up a second.
Like you cross it out.
If I would multiply these two polynomials together, I would get an answer that's x times x minus 2 times x plus 1 times x minus 2 times x minus 2. But that's not the least common not least common multiple. That's not the least common denominator. Because they share a factor in common, because they both have x minus 2, I can write it one less time. It's kind of like if I was asking for the least common multiple of, I'm trying to make it like harder, 6 and 9. It's like, oh, I didn't just multiply. If I was looking for the least common denominator 6 and 9, I don't just multiply them together. I say, oh, they both have a factor of 3 in common, so it's going to be less than what I think.
So you're basically crossing them out.
More or less, I'm like, okay, so I already took these into account, these two x minus 2's. Now I need to, is this answering your question? I need to include the x. I need to include the x minus 1. And then I have an extra x minus 2.
So what's the answer?
This one.
Oh,
This is
just x minus 2.
This is if you just multiply them together. Notice you have 3 x minus 2's versus in the actual least common multiple, you only have 2 of them.
Yeah, but you do another one like example 2a, just because I understand how to do that.
Oh, we're going to do plenty more of those.
Huh?
We're going to do plenty more.
Okay, 'cause I
For instance, example 3. So now that we've worked on least common multiple, we're going to work on adding and subtracting them. So I kind of started doing this with you already. So let's rewrite each expression with the least common denominator, then add or subtract. So this one's not quite so bad, right? Not so bad. I need to find the least common denominator, then rewrite it, then add it. What will my least common denominator be here?
To make it into 24 a squared.
24?
Yeah.
42.
Let's see.
14 times 2 is
Get
4 and then
It's
6
28.
times-
it's 28.
Oh.
It's close. You're close.
I was like,
Okay, so you gonna deal with the b's first?
well, then just
This has b squared, this has b. So what will my least common denominator have?
equal b2.
B squared. Okay. What would I have to multiply this guy by in order to get to b squared?
B.
Right, multiply by b, because b times b is b squared. Okay, I have the b's checked out. What about my a's?
A squared.
Yep, my least common denominator is a squared. The guy on the left doesn't even have a squared. Gotta write that in, because I'm gonna have to multiply by it. I'm trying to figure out what I have to multiply by as I'm figuring out the least common denominator. And lastly, what is the least common denominator of 6 and 14? So you can do it two ways. I'm going to show you two ways. First, I'll show you the way I kind of just showed you with prime factorization. Then I'll show you the way you've already known. So I have 2 and 3. 14's factors are 2 and 7. So I noticed they both have a factor of 2 in them. Awesome. They already both have a factor of 2. So I know the least common factor is going to be 2 times 3 times 7. How did I know not to repeat 2? Why didn't I write 2 twice? Because if they both have it in it, I only have to do it once. But guess what? Oh my gosh, 14. If 14 and 6 both had a factor of 7, cool. I'll write the factor of 7 once and highlight both times. That way I don't like accidentally repeat it. I didn't write 2 twice because they both have it in common. If they, yeah, okay, I don't know, I'm beating a dead horse. 2 times 3 is 6 times 7. 42 should be my least common denominator.
In Red Dead Redemption, you could beat a dead horse.
Awesome, I'm glad you're so on task. Okay, so next I'll show you the way you've done it in the past. List out the factors of 6. List out the factors of 14. Let's see. 42. So I see I have that least common multiple. Okay. So what do I need to multiply? What do I need to multiply 6 by to get to 42? Okay, so I have to multiply this guy by 7. What do I have to multiply 14 by to get to 42? Okay. So I found what I have to multiply the bottom by in order to get to this least common denominator. So I'm going to scroll up just a little bit, and I'm going to rewrite this. So I need to multiply by 7a squared b over 7a squared b. That's what I need to multiply 5a squared over 6b by. Because the bottom, when I multiply the bottom out, I'm going to get my least common denominator, which is 42a squared b squared. So I'll figure out the top in a second. Then I'm going to multiply by 3 over 3. That's what I multiply my second term by. 9 over 14 a squared b squared. Because when I multiply the bottom by this 3, it turns into my least common denominator. 42 a squared b squared. Then I can go back and solve what the top would be. Can I scroll up a little bit? Is that okay? So we figured out what we had to multiply the bottom by to get to least common denominator. But then I can't just multiply by 1 over that, because that's not math, right? We have to multiply by 1, right? That's the trick. Multiply by a clever form of 1. It's like a tricky trick. 7a squared b over 7a squared b, that's technically equal to 1. So I'm not really changing the problem if I multiply by 1. But what happens is I make it have the same denominator. Now I can go back and combine the top. So let's combine the left side first. All right, so I'm going to combine this first. 35, a to the 4th, b. Wait, why is it not like, 4a? Or how'd you find these?
Multiply them together.
7 times 5 is 35. A squared, so it's going to be a to the 2 plus 2. Because when you multiply bases, you add the exponents.
Yeah.
Okay, and then you just have the b. Okay, what about this other side?
Just 27.
27.
Special about that one.
Okay, so what am I supposed to be doing? Let's see. First rewrite each expression with least common denominator, then add or subtract. Okay, cool, let's add or subtract. How would I write this final answer?
35 to the 4, a to the 4th, b plus 27,
Hey, that's good. That's exactly what we do. I have it all over one fraction. Look at you doing fractions.
Yo. It's just too easy, you know what I'm saying?
Language.
This is too easy, you know what I'm saying?
Thank you.
Flex up on these math fools.
Did you know I was screencasting this?
Huh?
You know I'm screencasting this?
Oh, right now?
Yep.
I didn't know that. What for?
Cool.
Who's missing?
Maya.
Hi, Maya. Hope you feel better.
Okay.
Alright, I was kind of caught off guard there. I'm not gonna lie.
Well, you're late, so what do you expect? Okay, let's do the next
My
problem.
sister was late. I was in the car at 7:25.
Let's do the next problem. Come on. So, x plus 10 over blah, 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 blah. Okay, first thing, what should we do?
From 10 times 3.
Ooh, you said take out 3 over here? Okay, so I'll rewrite. This guy is x plus 10 over 3 times, what would it be? X minus 5. So I pull out a factor of 3. So I say, okay, 3 times what is 3x? X. More or less, I'm dividing by 3. Divide by 3, divide by 3. Okay.
And on the other side, you can divide by 6.
Jack, you doing alright? Okay, I'm just making sure.
Come
Alright, so I'm pulling out a 6 on the other side.
on.
Oh wait, it's also x minus 5? Ooh. Uh-oh, okay. Yeah, we could pull a 3 out on top. Do you want to do that? Okay. No, we could. Let's do it. Let's pull out a 3 from here. 3x plus 3. 5. Got it. Gotcha. Alright. Good job. Way to pay attention. Okay, so...
We could divide a 3 and 6 into a 1/2 question mark.
We could do that. Is that what you guys want to do?
Sure.
Alright, let's do it. So I'm just going to rewrite the whole thing because I want to be clear what's going on. So, Yarden said, we have a common factor here, 3 and 6. So it turns into a 2. So x plus 5 over 2 times x minus 5. Okay, so I need to be subtracting these, but before I can do that, I need to make sure they have a common denominator. How can I make this have a common denominator?
By multiplying 2 and 3 to 6. So you multiply 3 with 2 and 2 to 3.
So I multiply the left side by 2 over 2. Multiply the right side by...
3 over 3.
We just got rid of our 3 on the right side.
And we brought it back.
Is back. Alright. So this means I have 2 times x plus 10 all over 6x minus 5 minus 3 times x plus 5 over 6 times x minus 5. Okay, so now that I have the same denominator, I can actually, subtract them. But first, I'm going to distribute this out. That way I can actually subtract them. So I have 2x plus 20 minus 3x plus 15 all over 6 times x minus 5. So the reason I had to distribute on top is because I'm trying to make sure I'm combining like terms. Why did I keep the parentheses around 3x plus 15? So I can distribute the negative sign on the ball. Alright. I need to make sure I distribute the negative sign to both objects. So 2x plus 20 minus 3x minus 15 all over 6 times x minus 5. So I have negative x plus 5 over 6x minus 30. So I decided to distribute the 6 out on the bottom. And that's it. How do we feel about this? I'm doing alright? Okay. Do we need a little more time? Yeah. A little more. All right. Yeah, I think there's like 2 or 3 problems on the back.
But it says like the least common multiple, so the least common would be 6 times x minus 5.
Exactly. Sorry, I forgot to write that. Least common multiple is 6 times x minus 5.
Can I take lead of C?
Sure, walk us through this. Let's do it.
I have D.
Okay. You think we can get, yeah, we have 7 minutes. I think we could do it. All right, come on.
Okay, bam. You started off by distributing that quadratic, because, or like,
Distributing?
not distributing, like, turning into that thing.
Factor.
So we gotta find out what times what. Yeah, factor. What times what equals 18, but also equals, but if you add together, it's 9. So I'm gonna give the chance to the classroom. What?
Gross. Okay.
3 times 6 is the answer. So x plus 6 and x plus 3. 4x on top. And then we can see that there's a 6 plus x plus 6 both on the bottom. So we have an x plus 3 on the bottom as well. So what you gotta do, you gotta add that x plus 2 on the other side.
Multiply by x plus 3 over x plus 3. That means our least common denominator is what?
Our LCD is x plus 6, x plus 3.
Okay.
And then, basically, you get the whole shebang together. But now instead of it being 5, we're gonna like multiply together, so it'll be like 5x plus 15. So you got 4x plus 5x plus 15. So then you're gonna do 9x.
Plus 15? Oh, yeah, yeah. I don't know why I'm doing math wrong.
So that's gonna be 9x plus 15 to really make it like smooth and simple. And then you got your answer right there. Okay. So,
Good. That was a little fast, but it was good. It's good.
you know, this is like real life scenario for test taking, because I gotta be faster than test taking, all the time in the world. So I'm just trying to get people used to quick thinking. You know what I'm saying?
Sure. It was good.
Yeah.
We found the least common denominator. Turns out it was one of the denominators we had. It's like when you're trying to find the least common denominator between 2 and 4. Oh, you only have to change the 2. Okay. Let's try part D. Yeah.
Okay. So you want to factor the left side on the bottom first. You do 4x plus 1 times x plus 5.
How did you find this out?
Because 4x times x is 4x squared, and then 4x times 5 is 20x, and then 1 times x is 1 or x, so it adds it to 21x, and then multiplies to 5.
Good. So you're totally right. I just want to make sure we understand how we factored this. So what adds to 21, because that's your b, and multiplies to a times c. So what am I talking about? A times c. Do you remember? Quadratic equation, ax squared plus bx plus c. So I'm looking at the coefficients. So 4 times 5 is 20. So it multiplies to 20 but adds to 21. Let's see, like 20 and 1, right? Cool. So this is like how you do leading coefficients other than 1. So I think I've covered this before briefly, but I mean we're just going to keep working on it now. So I'd write this as 4x plus 20, 4x plus 1. So I take the leading coefficient, and then I write my two multiples, and then guess what? Both of these are divisible by 4. So this turns into x plus 5 times 4x plus 1. Is that a cool little trick? Like you write the coefficient, and then one of your terms can be like totally canceled out. You can like simplify. So cool. All right. Sorry. Keep going.
So then you take out a 3 and then 4 plus 4. Yeah.
Okay.
You multiply. Oh, okay, so on the left side, you're missing a 3, and on the right side, you're missing an x plus 5. So on the left side, you multiply the over 3.
Yeah, it's alright. Make sure I'm writing the least common denominator. So I see on the left side, you said you're missing a 3. Okay, so I'm going to say 3 times x minus 8. And on the right side, we're missing
X plus 5.
Jeez.
plus 6 times x plus 5. Awesome. Okay.
So then just like distribute that.
Mm-hmm.
And make it 3x minus 24 plus 6x plus 3. And then 9x. And you add all like right terms. So then it's 9x plus 6 over.
Awesome. Are we feeling a little more comfortable about this? How do we feel? Okay. Right, so E is a challenge problem. We do it like,
It just cancel, doesn't x minus 5 and x just like cancel out?
well, let's see. So I have x times x minus 5 over x times x minus 5. Yeah, they end up canceling. I just want to make sure I give you your work for next time. Okay, so I'm going to stop the screencast there.